Hello my class 10 students. This is the sample paper 1 of the ICSE Physics class 10 semester 2 examination. It is a paper of a reputed ICSE school and we are going to solve this paper. I have already uploaded this paper previously. I have already told you to pause the video and solve it. If you have not already solved this paper, then click the link that is here and solve it first and then come back and check the answers. Okay? Section 1 is for 10 marks with question 1 MCQs. A wire stretched between two fixed support is plugged in the middle and released. It executes which vibrations? Now here, these are not the resonant vibrations, they are free vibrations. But if they don't mention that it is in the vacuum, you could also write that they could be damped vibrations. Okay? Of course, they are not forced vibration because they are not under the influence of any external periodic force. The quality of the note from a particular string of a guitar is determined by. Now the quality or timbre depends upon the waveform. Where is the waveform? Here it is. So it's the option 4. The specific resistance of any unknown material is not affected by the change in. Now remember, specific resistance changes with temperature, but it does not change with pressure. Pressure is irrelevant. Applied magnetic field also is irrelevant, and it is not affected by the dimensions is the correct option here. Now why did I not say pressure or magnetic field? Because specific resistance is the resistance of unit length and unit area of cross section, which means if the material is this small or this big, it only takes the unit area of cross section and unit length, and it depends upon only that. It does not depend upon the dimensions. That is why fourth one is the correct option. Which of the following quantities has the same value for all the electrical appliances connected to the ring main circuit? The same value will be the voltage, because the voltage is 220 volts for all of us for our electrical appliances in India. The fifth one, the electric bulb is rated 60 watts, so that is the power, and 240 volts, so that is the PD, and when the switch is on, the current flowing through it. Now current means I, so we will say P is equal to VI, so your I will be equal to P upon V, so that will be 60 upon 240, and that will be equal to 1 upon 4, so that is 0.25 ampere, and so the correct option is 1. Sixth MCQ, when a current flows in a wire, it creates an electric field outside? No. A magnetic field around it? Yes. Both electric and magnetic field? No. Neither electric nor magnetic field. This also is irrelevant. The correct option is second one, because as long as the current flows, it has the magnetic field around it. Number 7, Lenz's law gives the direction of magnetic field? No. Motion of the conductor? No. It is going to give you the direction of the induced current. The current in the electrical circuit? No. It is all because of the electromagnetic induction. Eighth one, the SI unit of the specific latent heat. Now specific latent heat is Q is equal to MLF. So your LF is equal to Q upon M. Your unit of Q is joule upon mass is kg. So it is joule per kg, that is this. Ninth MCQ. The melting point of a substance increases by addition of impurities? No. Melting point decreases with addition of impurities. What does this say? Decreases with addition of impurities? Yes. It does not remain the same definitely, and first increases then decreases. This is also irrelevant. So correct option is second one. 10th MCQ, which of the following radiations suffers maximum deflection in the magnetic field? Now maximum deflection will be for the lighter particles. Remember, alpha particles and beta particles. They are the particle radiations, beta being the high speed electrons. It will be beta which will be deflected maximum. So that finishes our section 1 of 10 marks. Section 2 will have 3 main questions to be solved, and we are going to solve question number 2 first. Is it possible to detect the filling of a bottle under a tap by hearing its sound at a distance? Give reason for your answer and state the condition for resonance to occur. Now, in order to solve this, I'm going to use the answer sheet of one of my students, so it will go very fast. The video will not be very long. So we write the answer like so. Yes, it is possible to detect filling of the bottle under the tap by hearing the sound at a distance. As the water fills the bottle, the length of the air column decreases, and therefore the frequency of the sound increases because it increases the pitch and makes the sound shriller. And we write over here, frequency is inversely proportional to the length and the frequency is directly proportional to the pitch. Thus, we can detect the filling of the water bottle by hearing the sound. So that's here 2 marks here. For the resonance to occur, this is the second part of the question. There should be an external periodic force causing the body to vibrate, and the frequency of the vibration of the external periodic force should be equal to the natural frequency of the body. So that was for your 1 mark. We come to the next question. Question 2b, number 1, what are damped vibrations? Give one example. What is the subjective nature of amplitude? Now this part is learning work. I hope you have learned the definitions by heart. Even the example you should know by heart. Let us see how we write it. So we write the definition: the periodic vibrations of a body with decreasing amplitude in the presence of a resistive force are called as damped vibrations. And here we can write anything vibrating. The common example would be a tuning fork vibrating in air. You must mention that it is in air, because if you don't mention, it could mean that it is in vacuum, and so vacuum will have no resistive force. So 1 mark for this, 1 mark for this. Subjective nature of amplitude is the loudness, because it depends upon the person's receptivity, and we know that amplitude square determines the loudness. That finishes our second B part. Now we come to C part. Why does the weather become pleasant when it starts freezing in cold countries? And on the basis of high specific heat capacity of water, explain the formation of the sea breeze. And that is 2 marks each. So let us see how we write those reasons. Question 2c. The ice has very high specific latent heat of fusion, that is 336,000 joule per kg. Hence, each kg of water at 0 degrees C liberates 336,000 joules of heat energy to the surroundings to become 1 kg of ice at 0 degrees C. Now, this statement is very important. If possible, you can underline the keywords. This heat liberated by the water from the lake makes the weather a little warmer and pleasant. So that is how we write our give reason. The second one is about formation of sea breeze. For the sea breeze, we are going to say that the water has high specific heat capacity, which is 4200 joule per kg per degree C. It has a high specific capacity than the land. Hence, land gets heated up faster than the water for the same amount of heat supplied by the sun during the day. As a result, the air above the land will be warmer, rarer, and it rises, allowing the cool air from the sea to flow towards the land, forming the cooler sea breeze. So we write the specifications like this, and if possible you should underline the keywords like so. So that finishes our question number 2 of 10 marks. We come to question number 3. Draw a V against I graph for a conductor obeying Ohm's law. What does the slope of VI graph of the conductor represent? And this is for 3 marks. So 2 marks for the graph and 1 mark for this. Okay. So let us see how we write this. We draw the graph with our y-axis and x-axis here this way, and we must label the axis. Now V against I, so V will be on y-axis, and we write that V will be in volts, and I will be in amperes here. And also we need to mention that this is the origin and it's a straight line graph passing through the origin. So this becomes your 2 marks, but if something is missing over here, you haven't labeled the axis, 1 mark goes. So out of 2, I have given only 1 mark over here. And of course, the slope is going to be delta y by delta x, which will be delta v by delta I. And v upon I is equal to R by Ohm's law. So the slope is going to represent the resistance of the conductor. The first part, express kilowatt hour in joules. Second one, an electric bulb of resistance 500 ohm draws a current of 0.4 ampere. Calculate the power of the bulb and the potential difference at its ends. Let's see how we write it. So we write 1 kilowatt hour is 1 kilowatt multiplied by 1 hour, like so. And 1 kilowatt is 1000 joules per second, and 1 hour is 3600 seconds. Now when you multiply this, you will get 36 and these 4 zeros. That is 3.6 into 10 to the power 6 joules. That way also you can write. Avoid using megajoules because you have to convert it into SI units. So we have 1 mark for that. The second part, resistance and the current has been given and we are asked the power. We must know all the relations with power, current, the resistance and the PD. We must know all the relations. Now here we use P, R and I. So the relation we use is P is equal to I square R. I square is 4 upon 10 into 4 upon 10 and R is 500, and as you can see the zeros get cancelled. We have 4 5s 20, 4s 80, so 80 watt is the power. And by Ohm's law you can have V is equal to IR, so V will be equal to 0.4 multiplied by 500. That is going to be, we use these 2 zeros to shift the decimal here and it becomes 40 into 5, so that becomes 200 volts. So that is 1 mark for this, 1 mark for this. Let's move to the next part. Question 3C. What do you understand by earthing? Explain the function of the following in the household wiring: the fuse wire, the main switch and the 3-pin plug. Let's see how we write these answers. So earthing means conducting the excess current to the ground, that is allowing the current to pass through the earth when due to not some reason, but we can say short circuit or faulty appliance. And excessive current flows through the circuit and it goes straight into the earth. Okay. Then we come to the fuse wire. We have to write the function of it. What does it do? It melts and breaks the circuit when the current more than its safety limit flows through it. Thus, it protects the user and the appliance, and that's also for 1 mark. So we have each one of these 1 mark. Now the main switch, what is its function? It is a double pole switch which connects and disconnects the live and the neutral wire simultaneously, and it keeps the entire circuit of the house safe. So here the safety part was not written, so half mark is less out here. Now the 3-pin plug, it connects even the earth wire. Now remember, normally we have a 2-pin plug, but what is the function of 3-pin plug? In addition to live and the neutral wire, there will be earth wire also. So the earth wire will be connected to the 3-pin plug. It connects the earth wire also, which safeguards the circuit and the user in case of faulty appliance or short circuit by conducting excess current to the earth. Okay, so here you see, because this part is not mentioned, this student has got half mark less. Question number 4. In a nuclear reaction given, nucleus X changes to another nucleus Y, and this is how it has been given as the reaction. What are the atomic number and the mass number of Y? Name the gas formed when the alpha particle acquires 2 electrons. Now here this is the alpha particle. We have to write which gas will be formed. Of course, alpha is helium 42 but there is no electron over there. So if it accepts 2 electrons, it will become helium gas. And now here 226 will be losing 4 particles because the mass number is conserved, and so Y will be 222 and the atomic number will be conserved. So you'll have 88 minus 2 particles. So here it will be 86 as the atomic number. Let us see how we are going to write that down. So we've written the reaction here. This will be 226 becoming 222, and here we have 88 becoming 86. So we have atomic number 86, mass number is 222, and that is for 1 mark each. So we have 2 marks there, and this is the helium gas that is produced when alpha particle is going to accept 2 electrons, that is 1 mark here. We come to B part. For B, how is a negatively charged beta particle emitted from a positively charged nucleus explained? And that is for 3 marks. So obviously we'll have to write quite a bit of information there. So we write that in a radioactive substance, 1 neutron in the nucleus splits to form a proton and an electron. And this electron, which is with a high speed, cannot stay inside the nucleus, and so it is ejected from the nucleus in the form of beta particle. And this is the reaction. Reaction is important for you to show this. So we have to talk about the neutron splitting and then its components, the reaction, and because it's got high speed, it will be coming out. It cannot stay inside the nucleus. Now this was all for 3 marks, but because of certain words over here which are missing, and here it should have been splits, not disintegrates, so 1 mark is cut. So this is 2 marks for this question. Now we come to the next question, which is based on the diagram. Let us see the question first. Question 4C. The diagram below shows a small magnet placed near the solenoid AB. So you have the solenoid, and here we have the cell connected with the key here. The current is switched on in the solenoid by pressing the key, that is K here. State the polarity at the ends of A and B. Will the magnet be attracted or repelled? Give reason for your answer. Now we have the direction of the current this way because this is the positive terminal, this is the negative, and then we have the current going this way and coming back here and completing the circuit when the key is shut. Okay, now if you look from here, the current is going this way and going into. So if you are looking at it from this side, it will be going this way. So it will be anti-clockwise. That will give here the north polarity. B will be the south polarity. And we have to write just that. We have to state the polarity at A and B. So A will be north, B will be south. Will the magnet be attracted or repelled? Now this is the north pole of the magnet, and we have north pole here at the solenoid near end form. Between the like poles there will be repulsion, so it will be repelled. Give the reason. The reason will be when the current is flowing through the circuit. Because of the magnetic effect of the current, A is going to develop north polarity. Also we say since the current at A is anti-clockwise. So you must mention magnetic effect of the current carrying conductor and the clock rule, which tells that A is having north polarity. And then we say that the north and north, the like poles will show repulsion, and so they will be repelled. That will be for the reason. So that finishes our 4 marks. Let us see how we write the answer. Question number 5 I'm not doing because I just wanted 40 marks to be solved from here. So we have solved our question 1 of 10 marks. Then question number 2, 3, 4, each one is for 10 marks. And so we have finished with 40 marks. Let us see how we write the answers. So here we have the last answer here. A has north polarity and B has south polarity. So both of these will be for 1 mark here. The magnet gets repelled, 1 mark for that. And here we have to mention for 2 marks what exactly is happening. For justification, there will be 2 marks. The north pole of the magnet is facing A, which has the north polarity. How it was not polarity, I've already explained it to you, and the likes pole repel. And so that's how 1 mark has been given less for this answer, and that finishes our paper. We are not going to solve question number 5 as such. You can count your own marks and write in the comments how much you're getting, and also work well and work hard for your examinations which are coming up. All the best to all of you. Bye.